Hi, in this video I'm going to be showing you how to make a reverse polarity protection. What I'm saying is how to protect your circuits, your electronics appliances from burning or getting damaged whenever you switch the polarity of your battery. So it is called the reverse polarity protection in electronics. So we'll start it with Pro Tools, so I can just give you the theoretical aspect of it. So in the schematic, I do in the PCB layout and I do in the firmware. Like I'm not using a code and all that for it, and I'm good to go. So I'll add components, and now we want to select our devices. We need some things. We need a transistor, we need two resistors, we need the battery voltage source, and that will basically be all that we need. So now if you want to select a transistor, you have to select a transistor that will fit in what you want to use it for. That's a transistor that the drain to source current of the transistor will not be more than the current that your load is pulling. That's your device itself is pulling. You're trying to protect a device, and that device can be pulling up to an amp. So if the device is pulling up to an amp, your drain to source current for your transistor is supposed to be greater than 1 amp. And the rule of thumb I use for myself is that I multiply that current by 1.5 at least. That's the minimum, and I select a transistor that has that rating times 1.5 of it, and I use it for it, and I usually get the result that I really desire. So what do I do here? I now select a transistor. Now let's say you are designing the circuit that we're going to be pulling like 50 amps of current. Your best bet might be to use an IRF 3205. But now you know something, that once current starts flowing, there will be heat dissipation. To save your circuit and save the load, what do? You put current transistors in parallel, so you can increase their current rating. For this demo circuit, I'll be using IRF 3205. Just one IRF 3205. I'll need a resistor. Now I need to measure what is going out of this point. So I'll connect the resistor to the source. I'll connect this to the gate drive resistor. So I'm going to the gate now. But now you see this value is very high. It's too high. I'm not sure that it will be able to give us what we want. I'll edit this value, come to edit properties, edit the value to be 22 ohms. 22 ohms, that's 22R, and here we go, 22 ohms already. So I'll need to measure what I'm taking out from this, but there has to be a battery, because it's a battery you actually connect. You only reverse the polarity of a battery, or you're even using a power supply, but usually a battery. Sometimes you're just stressed out and you just miss the polarity. So this is what this is for. So I'll pick a battery. Then connect the battery. I've connected the battery. Now I will need something to measure the voltage of the battery and the output voltage also. But you see, this my connection is supposed to be the normal connection I'm supposed to use. But remember something, that there's a diode here. So it means that if I reverse the polarity, if I change the polarity, to on an N-channel MOSFET, you need a voltage greater than 0. So there will not be any voltage greater than 0 flowing through this place. So hereby this gate here will be off. That it means that it will be isolated, it will be off. But you see that this diode here will allow current to flow. So if I reverse the polarity here, it means that it will allow current to flow. So what will I do? I will now flip in the Y direction. So when I flip in the Y direction, I will delete these wires that are contradicting each other. Then I will do the reconnection of everything I need. So now here will be the ground for the input. Here will be one of the output, and this will be the positive output. The positive rail does not change. Only the negative rail passes through the transistor. So I'll place a multimeter, a measuring instrument. So I'll use a DC multimeter, and I'll place one at the output too. So I'll connect this here, I'll connect this here, I'll connect this here, and this one's already connected by virtue of how I dropped it there. So I will now go to simulation and I'll press play. When I press play, you see something that's very common here. This positive 12 volts and this positive 12 volts here. It means that this transistor is on and allowing currents to flow outside. Now let me put a load, a dummy load on it. Now I've placed a dummy load here. This is a 10k resistor. Ideally, the voltage is not supposed to drop. So you see now it's 12 volts here and it's 12 volts out there too. So now, you know, I told you that what if there was a scenario that you mistakenly switch the polarity of this battery. I'll delete this object. Now I'll place a battery, but I'll flip it in the other direction. Then I'll connect it. I'll press play and let's see what happens to it. Now you see that here it gives minus 12 volts. It means that this polarity has been switched the other way around. But here it's giving minus 0.02 volts. So it means that this is 20 millivolts as output. And you know, all diodes have their reverse leakage current that they can bear. You get what I'm saying? So even for the reverse polarity normal ones that you buy from other companies, you discover that they will still give you ratings for them. So this is basically all for the reverse polarity protection that we're going to be doing. This is the theoretical aspect of it. In my next video, I'm going to be showing you the practical way of doing it, the hands-on experiment, and I'll show you our result from the multimeters that we use. Thank you for tuning in today. Hope you enjoyed the video. If you enjoyed the video, hit the like button. If you want to get more update about other videos that we're making, you hit the you subscribe to the channel and you hit the notification bell, so that anytime we release a new video, you'll be updated and you'll be part of the first people to watch it. You can share the videos to your friends and stay creative.